We've talked before about gravitational potential energy as stored energy, that the energy that was done by work to elevate an object could then be transformed into kinetic energy, or the energy of movement when an object fell. But gravitational potential energy isn't the only kind of potential energy out there. And in this lesson, we're going to look at the elastic potential energy. Specifically, we're going to be looking at the elastic potential energy in a spring. But there's other kinds of places where you find elastic potential energy. If you've ever shot a rubber band, when you pull the rubber band back and make it stretch, you are building up elastic potential energy in that rubber band so that when you release it, it will fly across the room. Kinetic energy. If you're an archer, you pull the bowstring back on the bow, and that is increasing the potential energy. Notice that you're also doing work, just like we saw before, to increase that potential energy. Elastic potential energy is mechanical energy, just like our gravitational potential energy was. And so it will be conserved with the kinetic energy that it can be used to generate. Let's look at our example. A spring has a relaxed length of 0.4 meters. Has a spring constant of 32 newtons per meter. Now, I'll get to that in just a minute. How much elastic potential energy is stored in the spring when it's stretched to 0.62 meters? We have a spring here, and this spring normally has a length of 0.4. This is just hanging there being a spring. When we add a weight to that spring and we make it stretch farther, the force of gravity pulling down on that weight is exerting a force on this spring and causing it to stretch. And in this case, it ended up stretching an additional 0.22 meters. The spring constant that's given here, and sometimes you have to calculate it, the spring constant is how stretchy a spring is. How hard is it to pull that spring and make it stretch? We represent the spring constant with a K. Now, the formula for the potential energy that is elastic is equal to 1/2 K X squared. Now in this case, X is the displacement of the spring. So in our example, the spring got stretched 0.22 beyond where it was when it was relaxed. So that is our value of X. Our K is our spring constant that's given to us. So now it's simply a matter of putting in the numbers. Times 32 times 0.22 squared. Pull out the trusty calculator, and we've got 32 times 0.22 squared. And now I want half of that, so I'm going to divide by 2. 0.7744, we can round that to 0.77. And it is potential energy, so it's 0.77 joules.